All right, cool. Let's get started. So, we will start with the weekly check-in, because it's good for us to do that. And you guys have been away, obviously, for the holidays, so it's nice for us to kind of catch up and have this chance to have a little cuddle. So, first thing we'll do is the fun random question, which is about if you walked into any world, what world would you want to walk into? So kind of like a fictional world. It could be a book, it could be a movie, it could be a TV series. Person answering that question today is going to be Brooklyn.
Let's go, Brooklyn. Let's go, Brooklyn.
What world would you want to walk into? Huh? Eastworld. I haven't actually watched Eastworld, but I heard it like, huh? Oh, H2O just out of water. I have heard of that one. That's the mermaid one, eh? That's a cute one. Would you want to be a mermaid though? Yeah? You want to be one of the mermaids? All right, I'll pick someone else because I like this question. Tupol, what about you? What world would you want to walk into?
Transformers.
Huh? Transformers. Yeah, that'd be pretty cool. I think I would want to, I was debating this and I was like, do I want to walk into the world of Marvel or do I want to walk into the world of Harry Potter?
I chose Harry Potter.
And I chose Harry Potter because I figured, like, the thing that's special about the world is, like, in Marvel you get to be a superhero, but in Harry Potter you get to be a wizard. And I feel like there's not as many superheroes as wizards. And then on top of that, like, you could just be an ordinary wizard, whereas if you were a superhero in Marvel, then you'd have to be, like, a hero or something. So, like, that's a lot of pressure. Or you could be a villain. But I decided, you know, at least with the wizarding world, I could just be, like, a run-of-the-mill, day-to-day wizard. I don't need to do anything to save the world. Was my thought process. So, very silly kind of thing. All right, micro goal for this week. So basically, what are you trying to accomplish? Doesn't need to be anything that's school related, if it's just something else, but the person answering that today is Mata Michelle. Yes. What's your goal for this week? To pick a color? Oh, for your ball dress. Oh, yes. I know the ball is on everyone's mind. It's hard to choose as well. And then you try to like match and like coordinate and you got to think about your shoes and your hair and all that. Yeah. All right. I know the ball's on a lot of people's minds. Don't forget to pay for it also. Anything else that anyone else wants to share before we move on to the content? Are we good? All right, content time? All right. Cool. So let us switch gears and talk about what we're learning this week. Just to recap last term, you guys were doing ion identification, which is an example of the qualitative analysis. And qualitative analysis is basically asking the question, what's there? You guys learned how to identify cations and anions using a flowchart, and that's just one example of qualitative analysis. There's lots of different ways we could try to figure out what's there. What I want to then move on to for today's lesson is starting, actually I should backtrack. Last term we just focused on up to the merit level material. So today's lesson is going to start looking at that excellence level material. So really kind of honing down and getting all of the assessment ready to go. Cool. I should also point out I've written on the board when you guys are going to be doing your assessment, and it's probably going to be next week because we're basically done with the material. I'll double check. I'm pretty sure I was thinking about starting it on the Wednesday. And basically the idea with this assessment is I'll give you 2 ionic compounds. You have 2 opportunities to show me that you know what you're doing. Are we good? But I don't want you guys to freak out. Most of you guys are perfectly fine, and this should be easy peasy. You've done a lot of practice, obviously, beforehand. All right. And the last thing we should think about before we jump into our lesson is our weekly fakatoki. In this case, we have ko atu tahi te fetu tarake o te rangi, which is canopus, which is a star up in the sky, is visible out in the open expanse of the sky. The other way you can think about this fakatoki is an outstanding individual. I think this is a good one to have for the first week back because you're now starting to socialize with all your friends again and seeing your teachers again. So you think about who are the outstanding individuals in your life. Make sure you really appreciate them. Also think about yourself and how you are going to be an outstanding individual. So I think it's a great one to have as a start of term. All right. Other things for today's lesson. It's going to be very kind of teacher focused at the beginning. I'll try to make it a little bit quick so you guys have a chance to do some practicals and things. I just want to remind you guys of some of the routines. Then I will talk about ion identification and I'll just kind of mop up, revise it as well, just so you guys can remember what the context of this assessment is. And then I'll talk about complex ions, which is what we need for the excellence level stuff. Then you guys will have a chance just to do some more practical practice. I want you guys to make sure you can do this because it is a practical based assessment. And then we will wrap up with Mahi choice. So you can either do some more practical practice or you can just do some theory practice. I'm not too fussed. Are we good? Okay. So with the success criteria, we're now going to be able to tick off the last two things, number 8 and number 9. Number 8 is on the balancing of the complex ion equations. Again, like I said, this is the excellence level stuff. I would suggest that if you are aiming for merit, give the excellence a go because it's not that much extra. The big jump is from achieve to merit. So if you're already putting that effort in to get to the merit level, just do this little extra add-on to get the excellence, or at least attempt it. Would be my recommendation. Like, it is ridiculous how little you need to do for excellence in comparison to merit. And then I'll also talk about what you guys need to do for the discussion component of this internal, which is thinking about the human and environmental impacts of these ions that we're talking about. So that's the research kind of section. Are we good? Okay. So some routine reminders. Some of you guys already heard this in bio. Make sure that your phones are away in your pocket or your bag. I don't want them on the table because I think they're very distracting. I can see people shuffling. That's good. If you guys need to Google things, because I know I want you guys to have that self-agency to look things up, use your devices. That's why the school has issued you a device. There will be a handful of instances where I understand that the phones need to be used. So like, for example, if you're looking up the answers in the SciPad, I know it's a QR code, and I know it's easier to scan that with your phone than your computer. But please let me know that you're doing that so I don't scold you for taking your phone out. I am mindful that things like that need to have that flexibility. Cool. I have noticed some people charging phones with the power outlets or through their computers. One, it's kind of a safety concern because we do all our practicals on the side, but also I don't want you guys to drain your computer batteries. So as our nice little compromise, in my closet I have a power strip and I have a box filled with chargers and cables. So even if you don't have your charger or cable, I got some. You're welcome to charge it in my class, but you need to charge it in my closet so that way it's not distracting you. So yeah, just wanted to offer that. Some things that I've changed with my routine procedure, just because it's now been a term and I've adjusted to Edgewater and things. Loan Shark, I've decided for the seniors, I don't need to collect collateral from you guys, and you guys are pretty responsible. So just go ahead and help yourself to whatever you need and just make sure you return it at the end. That kind of streamlines us as well. I also figured you guys are a bit more responsible than the juniors, so I won't issue bathroom passes for this term, but if you do still have your bathroom pass from last term, I'm happy to give you the points for it. So I hope all that makes sense. Yep. And then the last thing is I'll still keep those lolly charts because I think that's a great kind of reward for you guys, and stickers are fun. Cool. All right. So let's do a practice write-up for the identification component of this assessment. I'll pass out a sheet for you guys to work on. There is digital copies of it. I'm sorry it's kind of photocopied a little funny. The photocopier grabbed the paper in a strange way, so you're going to have slanty writing. Yeah. I have obviously lots of spares, so if you guys want to grab some later to do practice write-ups, you're more than welcome to. So I have made a slight tweak to the template. That's why I want to give you guys a new copy of it, so you can see how I changed it just a bit. All right. Once again, we'll use Science Scribe because I like being able to show you guys videos on the screen. Then let me get my Achieve, my Merit, and my Excellence colors. Cool. Hello, Wi-Fi. We need you again. Let me grab an old one just so you can see how I've changed it as well. Oh, I need the flow charts. So like the little rolls. Is my internet working again? So unfortunately, our staff internet is not working. So I'm just gonna hotspot. Yeah, because the staff internet isn't working. So that's why I'm hotspotting myself. There we go. All right. Cool. All right. Are you ready for me to start? Yes? Okay. So first thing I want to do to point out is the template. So what you guys might notice with the template is that I've changed it slightly. And the reason why I've changed it slightly is because over the holidays I was writing your assessment and I was doing some research to make sure I had the guidelines correct. And I noticed that actually based on the feedback that NZQA has given me, I needed to tweak some of it. So I want you guys just to be mindful. There is a small change in the template. And I'll give you guys some new instructions about the details that we need because I want to make sure you guys meet that qualification for the merit and the excellence. So the main thing that has changed is instead of having two separate boxes where you wrote your justification and equations, I put it into one box so that way you have a lot of space and it's basically the full thing will be kind of your justification section. With that justification section, you're obviously going to be identifying precipitates and writing your equations as well. So it's one spot for everything to kind of go into. But you still have the experimental steps, you still have the observations. So that's staying the same. Are we good so far? So that's the first thing I want to point out, and I'll show you guys how I want you guys to write your answers in this updated template. The other thing we need to keep in mind, now that you guys know how to do cations and anions, the purpose of this assessment is so you guys can figure out the ionic compound. So it's you don't just need to figure out the ions, you need to also state what the ionic compound is. So when you're doing this practical, you're obviously going to do the first steps to figure out what the cation is, and then you do the next steps to figure out what the anion is. So you guys should realize that this page is double-sided. One side for the cation, one side for the anion. Are we good so far? So today we're going to actually start using the full template. So before you guys were just doing one or the other. Now we're going to start putting it together and thinking about it as the ionic compound. The other thing that you'll notice that's new, because we're now talking about the ionic compound, is the last step here. Based off this experiment, the unknown ionic compound in the solution is, and then you write your answer. So basically you're taking what you've identified as the cation, you're taking what you've identified as the anion, and then you're identifying what the compound is. So that's the very last step. And unfortunately, you do need to do this for the achieved. Okay? So basically, we're just taking the two things we've talked about last term and putting it together into one. So what we're going to do in today's lesson is I'm going to model one write-up for the cation, and then you guys will do the practical and write-up for the anion. Cool? All right. So for the cation, we're going to do that video again because I think it's nicer and easier to see it on the screen. And the thing with this video is now it's going to be able to go up to the excellence level because I'll talk about complex ions. So, off the Science Scribe website, we are doing Cation C. So I'm going to write on my sheet that this is Science Scribe. Cation C. So that way we know what we're doing for our write-up. So I'll put that there. Cool. I'm sorry, it's photocopied very slanted, so you're gonna have to like slant the paper. The photocopier machine kind of grabbed it very badly. All right, are we okay so far? All right, so we are doing a cation identification. So here's our first video. If we were looking at our cation flow chart, let's pull that up real quickly. The first step whenever we're doing any cation identification is we need to figure out, we need to add 2 drops of sodium hydroxide. And remember, it's really important that you only add those 2 drops. So we're gonna write that down as step number 1. Remember, writing down your steps are your achieved. So we're going new sample. Because you're starting, well, I guess you don't need to necessarily write new sample. It's like sample. I'm just writing new sample. If you want, I can just put that in parentheses. Because it's technically all new samples. All right. So what we're going to be doing is adding 2 drops of the sodium hydroxide, NaOH. And I figured that out based off of my flow chart. That's always step number 1. Cool? All right, shall we watch the video and see what happens?
Yes.
Yes. All right, here's our video. So here's our unknown solution that's being entered. It's kind of a yellowy color. Like pee, like urine. And then we're going to do 2 drops of the sodium hydroxide, and we're going to make some observations.
That's a precipitate.
That is a precipitate. What color is that precipitate?
Oh, it's orangey.
It's like orangey reddy.
Brownie.
Yeah. All right, so back to our flow chart. So first thing we do, step number 1, what were my observations? There was like an orangey red precipitate. So like an orange-red precipitate forms.
Can I write PPT?
Yeah, if you write PPT, it's fine. I'm a lazy. It's okay. All right, so when we're looking at that flow chart, we see that we've done the 2 drops. So I'm going to start looking. So it's not that one because that says no precipitate. It wasn't a white precipitate. It's not a green precipitate. It was an orange precipitate, and that suggests that it's iron 3, right? All right, so we're going to hold off on doing the justifications and precipitate identifications. What I want to do first is figure out what I have. So if I'm looking at my steps, my next step is to have a new sample, and we're doing 2 drops of potassium thiocyanate, which is what the KSCN is. So let's write that down. Step number 2. Do you want me to go back? So, orange, we're going to do new sample, and we're going to add this potassium thiocyanate to it. So I personally like to write down all my steps of my experiment first, and then I do my write-up justification. So new sample, and we're going to add 2 drops of KSCN. So step number 2. All right, let us write down, or sorry, let's make our observations first. So if we look at our little checklist of items, we want new sample, add KSCN, thiocyanate. All right, ready? Video time? Video time. All right, so there's our original sample, and it's the new sample. And we see that's that yellow. And then we add potassium thiocyanate. And we're just basically confirming. So we think we have iron 3. This is a way for me to double check that I have it. It is very dark. It looks kind of like very like blood red. All right, so observation for step number 2 is that we had a dark red solution formed. So what does that tell me? I have iron 3. Cool? Yep. That would be marked wrong because it's not a precipitate. It's not solid. It's dissolved. Okay? So we need to have the word solution. Okay? All right, let's talk about the justification and how that's going to fit for the achieve, the merit, and the excellence. So, for the achieved, I need to see that you understand procedure and what you're doing. So if I see that you've done this first step, and we see that we have an orange precipitate, I would want to see for your justification for step number 1 that it suggests iron 3. So result suggests iron 3. Are we good so far? All right. If then I look at step number 2 with that dark red solution that formed confirms iron 3. So I'm going to write that as my next justification step. And I'm going to leave some space because I want to show you guys what the merit and the excellence looks like. So it confirms iron 3 is present. Is present. The other thing I would need you to do for the achieved is to figure out what that precipitate is. So if I look at that, I had iron 3, and then I had the sodium hydroxide. So which ion do I want for that? So if iron as my cation, what's my anion? Sodium or the hydroxide? The hydroxide. Oh my God! What do I want you to do as backup in case you do the formula wrong? Write the name. So this is iron 3 hydroxide. So I'm identifying what the red PPT is, I should say. All right, shall I keep going? All right. What I need then for the merit and the excellence is a little bit more detail for your justification. So In this case, we have been using the flow chart and we know that this red precipitate suggests iron 3, but I want to see that you've been able to process other things out and why it's not the other thing. So for example, we were thinking about what it is not and why is it not that. So for the merit to get to M, you need more detail. So if we're thinking about more detail, I have been able to rule out the ammonia and the sodium. Why can I rule out ammonia and sodium? Because that's a precipitated form.
Yeah.
So I'll write that down. Not or sodium because PPT formed. All right. What else can I rule out and why? How do I know it's not aluminium, zinc, lead, magnesium, barium? What's the color for that? It's a white one. Did I get white?
No.
So again, I want to see more layers. You can say, since the PPT is red, it rules out other colored ions. So like for example, can't be aluminium, zinc, lead, magnesium, or barium, since those precipitates would be white. The only red precipitate is which one? Out of that list, the iron 3. So it's a little bit more detail than we've talked about previously. So what I'm looking for in your justification then is why you know things are not there. So it's a little bit more detail. I know before we just made a list, but looking at the clarifications, you do actually need to write and explain. The other thing you're going to need to do is explain how you know what the precipitate is. So, for example, if I look at the precipitate with the iron hydroxide, I know that's going to precipitate because of the solubility rules. Yeah, Ruben.
See on the bottom line on that zinc, right?
This one?
Yeah.
Zinc, yeah.
ZN.
Yeah.
I thought it was
Z. And then we should also be justifying our precipitate. So we know that iron hydroxide is the precipitate because we know all hydroxides are insoluble. Are we okay with that? Do you know how I found that? Yeah. Since those precipitates would be white, only red precipitate is iron 3, so it has to be iron 3. I'll fix that so that way it's a little bit neater. Cool. This one here is from the solubility rules, that last line. Iron hydroxide is a precipitate because all hydroxides are insoluble. When I look at my list here, I see that. Where is it? All oxides, hydroxides are insoluble except with group 1. Is that a group 1?
No.
So we could also write that iron 3 is not in group 1. It's a little bit squished. Still haven't gotten the equation done. I might, do I have some twink? Or just cross it out and move it down? Sorry, I'm just going to move this down because it's squished. All hydroxides are insoluble. Iron 3 is not in group 1. Nah, insoluble. All right, are we okay with that? So it's a little bit more detail that you guys need to have for your justification. That's what the clarification says, so I want to make sure you guys have it. So basically what I'm looking for is that you're explaining to me how you know it's iron 3. So you should be using the flow chart and you should be using the solubility rules. Are we good? All right, last thing you would need to have then. So we've done the justification, we've done the precipitate identification, we still need to do the equation. Remember how I said with equations, you should start with the solid and work your way backwards to balance it. So iron 3, and that's aqueous, and then hydroxide, which is also aqueous, and then we see that there's a 3 here, so we put a 3 in front to balance it. I'm just going to rewrite what I had up there in red. Cool? All right, shall I keep going? Are we okay with that so far? All right. So this one here, number 2, that deep red color is actually the result of a complex ion. So I can confirm that it's iron 3 because the deep red or the dark red ion is a complex ion. So you see how I'm adding some more detail. Not only have I confirmed iron 3, but I know it's iron 3 because that dark 3 is the result of a complex ion. Now that complex ion stuff is now going up to the excellence level. A complex ion. So I need to figure out what that complex ion is, correct? So how do I know? Guess what? I've given you a list of complex ions. Where's my computer? Come on. No. Sorry, I need to restart my document camera. So, I'll show you how I know. I'm just trying to unfreeze my computer. All right. You see how I've given you a list of complex ions? Yes? So, with that complex ion, what I'm looking for is iron and thiocyanate. So, that's silver, that's aluminium, there's my iron. So that's how I know that's the complex ion. Shall I do that again? Okay. So, I'll point it out actually on the flow chart because it's a bit better. Do you see how we have sections here where the precipitate disappears?
Yes.
So whenever that precipitate disappears, we have a complex ion forming.
Yes.
Yes? So I need to know what that complex ion is. I have a list of complex ions provided. So if I know what the ion is, and I know what I added to the solution, I can figure out what the complex ion is. Okay? So when I'm looking at these instructions, I know I have iron 3. And I know in this step I added thiocyanate. So I'm looking on this sheet for a complex ion that has the iron and the thiocyanate. So that's how I know that's my complex ion. So, do you want me to do it again?
Yes. Sorry.
Okay. So, on this flow chart, whenever I see the word precipitate disappears, I know there's a complex ion. All right? Now, the reason why that precipitate is disappearing and what a complex ion is that base molecule is soluble in solution again. So I can make things that are precipitates unprecipitate if I have enough of the other ion that I need available. So in situations where you're going to add excess sodium hydroxide, ammonia, or thiocyanate, you'll notice that precipitates disappear. That's why the 2 drops is important, because if I accidentally add more than 2 drops, I could skip the precipitation step and go straight to the complex ion, and thus misidentify something. Does that make sense? Yeah. All right. So these complex ions are these giant sort of ligands or molecules, and what happens is this ion can have multiple things attached to it and thus make it soluble again. But it only happens when I have enough added to it. That's why we have to add it in excess. So if I add 2 drops, it forms a precipitate. If I add more, I then have enough to form the complex ion, and that's why things start dissolving. So what we then do, and then it's soluble. So that's why the precipitate disappears. In this case, there wasn't a precipitate that was disappearing. It was just that deep red color. So what I need to then do is figure out what that precipitate's formula is. Now, the nice thing on this, they used to not give you the list, and you would used to have to memorize these. Now they give it to you, so you don't have to memorize it. So what you then look for is what your ion that you've identified is and what you've added to it. So in this case, I'm taking that iron with the thiocyanate, and that's going to be my complex ion. Well, I know it because I know I have identified iron 3, and I know what I added to solution. That was a potassium thiocyanate. That's how I figured it out. Okay? Oh, makes sense? Easy. If I was using my flow chart, and let's say I was looking at the aluminium, you see how in this case, the aluminium initially makes a precipitate with the 2 drops of the sodium hydroxide, and then when you add excess, it disappears, and that's forming the complex ion. And since let's say we identified it as aluminium, then I would be able to go to the list and look to see where aluminium is. We added excess of the hydroxide, so I know this would be the complex ion that forms. You see how you're going to use that flow chart? So you're using the resources that are available to you. In some cases, remember how you have the 2 drops and then the excess. In this case, we're doing ammonia. Remember how I said those 2 drops of ammonia acts like a hydroxide, so that's the first precipitate. And then when you add excess, it's going to form the complex ion with the ammonia instead. So it can displace the hydroxide. And again, you just look on your list and you go, oh, it must be the zinc with the ammonia because that is what is disappearing. Zinc is kind of hard because there's 2 complex ions, so there's 2 ones that can form. First one here, and then a second one here. We can do zinc as practice so you guys can see it. So are we okay with that so far? All right. In this case, there's no precipitate disappearing, so I don't need to state the precipitate disappears because a complex ion forms. I can just state the dark red colors because of a complex ion. But if we had a precipitate that disappeared, I would say the precipitate disappears because a complex ion forms. Cool? The thing you also need for the excellence is the equation for the complex ion. Again, use the same technique. Use the flow chart, use the resource, write the ion and then work backwards. The thing to remember with complex ions is you need the square brackets around it. If you forget the square brackets, you won't be marked at excellence. And that's the way we communicate in chemistry that this is a complex ion. So I would write down bracket FeSCN, close bracket, 2 plus, and then aqueous. Are we good so far? No? All right, keep going? Okay, now I need to put down what my reagents are. So we have iron 3 and we have SCN. Both of those are aqueous. But the one thing I don't have right now is the charge for the thiocyanate. What is the charge is a good question. So let's think about it logically. I see this is positive 3, and this is now positive 2. So what number should this be to bring it down to 2? Positive 3 plus what equals positive 2? Negative 1. Basic math. If you forget that, you can use the flow chart as well. Yeah? So you see how we call it potassium thiocyanate? Potassium has a +1 charge. Thiocyanate has a -1 charge because together they equal 0. So there's multiple ways you guys can figure out the charge of that if you don't have it. Are we good? All right. So you see what I'm saying? The achieve stuff is real basic. Just tell me what you're doing. The merit is obviously a big jump because now you need to start and explain why you're doing each step and how you're using the flow chart. And then the excellence isn't that much extra. In this case, the excellence was just writing the complex ion equation. Yeah? So you might as well give the excellence a go. All right? Are we good? Okay. I think I pointed out most of the things I want to point out. One thing I do want to point out on the anion flow chart, we have red litmus, and we see red litmus goes blue, and red litmus goes or stays red. Do you guys remember what the litmus paper is doing? Indicate pH. So if it turns blue, what does that tell me? It's a base. Not basic. Not necessarily acidic. It could be neutral. It could be neutral or acidic. If it turns blue, it has to be a base. Is carbonate a base? Yeah, because when you add it to an acid, it bubbles, makes carbon dioxide. Is hydroxide a base? Yes, that's the main component in bases. So you see how that's going to be your justification. Yeah? Red litmus stays red, therefore not a basic ion. Not hydroxide, not carbonate. Cool? All right, I'll give you guys one more thing to think about, and then I'll let you guys have a chance to write up the anion. Does that sound like a good plan? Okay. All right. Before I move on, what questions do you guys have? None? I see a lot of head shaking no. Okay. Yep. So it's aqueous. So you remember how when we were talking about structure and bonding, and we're talking about ionic compounds, and some ionic compounds are solid, and some of them are aqueous in solution, and it has to do with the attraction between the water molecules and the ions versus the attraction to themselves. So with these precipitates, the attraction is preferred to be with the ions, making it a solid. When we have these options of the complex ions forming, the new complex is actually attracted to the water molecule, and so that's why it's gaining that solubility again. You don't need to worry about explaining the reason why something is soluble. You just need to refer to the solubility rules. You just need to tell me complex ions are soluble. You don't need to explain to me why complex ions are soluble. You just need to state that they are. Okay? Cool. All right. What else do you have to ask? Are we good? All right. Shall I talk about the last section of this report and then you guys can do some practical? All right. Ready? Are we okay to move on? I hear a lot of like chit chat. Do you guys have questions that you need me to answer? No? All right, shall I talk about the last section so you guys know exactly for this assessment and you'll be ready for next week? All right, the last component of this assessment, so this first bit here that we are writing up, that's the practical component to help you identify what ions are there. And once you know what ions are there, you then have to write a report. Now, it's not a big report. It's basically kind of like a couple paragraphs. And you need these paragraphs in order to pass. So we need to think about impact. So if you're just aiming for an achieved, for at least one ion, I need to hear 2 ways that that ion affects human health or affects the environment. You just need to state like something. So it's basically like 2 sentences. I would like you to write up both ions that you have in your ionic compound so that way you have a backup. So if you make a mistake, I can give you another chance at it. Are you okay with that so far? For the merit, you need to explain why. So you've identified what the problem is. You explain why it has that problem. And you need to give me 2 explanations. So most of these ions will have multiple issues. And again, you have 2 ions in an ionic compound, so you get 2 chances to show me that you can do that. Are we good so far with that? So that's what the merit is. The excellence is obviously a discuss, so it's a little bit longer. And in that case, I want you to think about pros and cons. So a lot of these ions are actually beneficial at low concentrations and toxic at high concentrations. So an excellence level student understands that it's not just black and white, it is actually like a spectrum. Again, you're thinking about human health and you're thinking about the environment. And the main thing you need to do for the excellence then is relate it back into the dose or the concentration of that ion. Are we good so far with that? So you're going to do a little bit more research, obviously, because you're going to talk about the pros and cons, and you can say, look, at this concentration, it's beneficial and does this. At this concentration, it's toxic and it does that. Cool? And that's the excellence level. And that excellence level will actually start us thinking about our internal that we do after this one, which is titration, and about how do we then quantify concentration. The thing I like to say when it comes to this is something that my supervisor said to me in toxicology, which is everything is toxic, it's just a matter of dose. So everything's toxic, it's just a matter of dose. Water could kill you if you drink enough water and you don't wee. Yeah. And someone actually died doing that on a radio contest, which was really ridiculous. And the thing is, nurses were calling and like health professionals were calling and be like, this is really dangerous, don't do this because she's gonna die, and she did, because her brain swelled. So everything's toxic, it's just a matter of dose. If you're thinking about the excellence level, you should be thinking about that theory. Okay? And because there is that report component to it, I will be checking it for plagiarism. Okay? Cool. All right, so you guys have, we have done the cation identification. I will go grab the solution and you guys will identify the anion and do the practice write-up. Cool, and then together you'll be able to tell me what the ionic compound is. All right, cool, let me get the stuff out. You guys, it's the same sort of setup as before. I'm gonna get you the stuff for both the cations and the anions because you need to be able to start thinking about both. Yeah. So the only thing I need you guys to pack up are the test tubes and the test tube racks and return my unknown. You guys are welcome to keep the ice cream boxes, return your goggles. Just a reminder, before you guys run off, on my Google Classroom there is that Mahi choice, so you guys know what you can do for practice. But we'll still keep doing more practices in class. So today we talked about complex ions. Remember, that is the excellence level stuff. If you're not aiming for excellence, you don't have to worry about it, okay? Cool. All right, keep getting some work done, and I'll see you guys, I think, later this week. Make sure you wash your hands and you spray the tables down. See you later.